In this access method, we use standard Ethernet uses one persistent CSMACD. What is the CSMACD? We already learnt in the previous chapters, but abbreviation of the CSMACD is carrier sense multi-access collision detection. Carrier sense multi-access collision detection. Here, next will be slot time. Slot time will be given by round trip time plus time required to send the jump sequence. The slot time in an Ethernet network, the round trip time required for a frame to travel from one end of a maximum length network to the other plus the time needed to send the jump sequence is called slot time. The slot time and maximum network length. Maximum length will be calculated by using propagation speed into slot time divided by 2. Maximum length of the traditional Ethernet is reduced to 2500 meter because of the delay time in repeaters and interfaces and the time required to send the jump sequence. Next will be the efficiency of the standard Ethernet. Efficiency of the standard Ethernet will be calculated by using, and it is defined as the ratio of the time used by the station to send data to the time the medium is occupied by the station, and it is the practical efficiency is given by efficiency is equal to 1 divided by 1 plus 6.4 into alpha, where alpha is number of frames that can be fit on the medium, and alpha is also calculated by using propagation delay divided by transition delay. Next will be physical layer. The standard Ethernet defines the several physical layer implementation. 4 of the most common are given in this figure. First one will be 10 base phi, 10 base 2, 10 base T and 10 base F. In this, what is the 10? 10 stands for the standard data transfer speed over the media, and here base stands for baseband, and here phi and T is given. It can be number or alphabet. It gives the segment length. And base phi uses a bus topology and thick coaxial cable, and 10 base 2 uses a bus topology and thin coaxial cable, and 10 base T, here T stands for twisted pair, and it uses star topology and UTP, and 10 base F, F stands for fixed, and it uses star topology and fiber. Next will be encoding and decoding. In encoding and decoding, sender and receiver will be there. At sender side we use Manchester encoder, and at receiver side we use Manchester decoder. What is the meaning of Manchester encoding? Manchester encoding is a synchronous clock encoding technique used by the physical layer of the OSI model to encode the clock as well as the data for a synchronous bit stream. Whenever we transfer data will be transferred in a digital form only. Whenever we transfer 10 Mbps data to the Manchester encoder, it will encode the data and it makes the digital form, and it will be transferred over the cable twisted pair of fibers. And at the receiver side, Manchester decoder will be there. It will decode the digital form data and it will convert the original form. This is about encoding and decoding. Next will be 10 base phi. 10 base phi it is also called thick Ethernet, and it is another name is also called thicknet. It uses bus topology and external transceiver and connection of the station to the medium using 10 base phi. Here in figure 13.10 it is given implementation. It uses thick coaxial cable of the maximum length 500 meter, and it is using transceiver cable maximum length is 50 meter. Next will be 10 base 2. It is also called thin Ethernet. It is another name is also called cheapernet. It uses bus topology and internal transceiver or a point-to-point connection via external transceiver. It uses a thin coaxial cable and its maximum length will be 185 meter. Next will be 10 base T. Here T stands for twisted pair, and it is another name is also called twisted pair Ethernet. It uses a physical star topology stations connected to hub with the internal or external transceiver, and it uses two pair of UTP cable. 10 base F, here F stands for fiber, and 10 base F it is also called fiber Ethernet. Fiber link Ethernet uses star topology to connect stations to a hub, normally implemented with the external transceiver having two pair of fiber optic cables connecting it to the hub. Here in figure they given two fiber optics, they are connecting to the hub. And in summary, 10 base 5 uses a thick coaxial cable, and its maximum length will be 500 meter, and it is using Manchester encoding. And 10 base 2, it is using thin coaxial cable, maximum length will be 185 meter, and it is using Manchester line encoding. 10 base T, it is using 2 UTP medium and 100 m maximum length and Manchester encoding. And 10 base F, it is using two fiber media, and maximum length will be 2000 meter, and it is using Manchester encoding. Next will be changes in the standard. The 10 Mbps standard Ethernet has gone through several changes before moving to the higher data rates. These changes actually opened the road to the evolution of the Ethernet to become compatible with other high rate LANs. And the topics discussed in this sections are bridged Ethernet, switched Ethernet, and full duplex Ethernet. First will be bridged Ethernet. Here, what do you mean by bridge? Bridge is nothing but it separates the LAN into different segment. And bridged Ethernet is the first step in the external evolution was the division of the LAN by bridges. And bridges has two effects on the Ethernet LAN. They raises the bandwidth and they separate the collision domain. And here raising the bandwidth, here in diagram they given sharing the bandwidth. If one station is there and it is sharing the data over a network and it uses 10 Mbps, but if two stations were there, the cable, the bandwidth will be scattered in between those two stations, so that first station will be using 5 Mbps and second station is using 5 Mbps. This is the meaning of the above diagram. And next will be the network with and without bridge. Here in below diagram they given network with bridge and without bridge. In without bridge, all PCs were connected, all 12 PCs were connected to the LAN using coaxial cable, and here the chances of collision will be more. And in with bridge will reduce the chance of collision. How it will reduce the chance of collision is, if I already told the bridge separates the LAN into two segments, or separates the LAN into different segments. For example, if here 12 PCs were there, it will separate 12 PCs in 6 and 6, and 6 PCs will come in segment 1 and 6 PCs will come in segment 2. If PC1 wants to share data to the segment PC12 in segment 2, then MAC address of the PC1, MAC address of the PC12 will be given to the bridge. If bridge is having the table of MAC addresses, it will compare the which PC MAC address will match with which PC, and that it will transfer the data to the particular PC which is having that MAC address, so that there is no collision of the data. This is about this. Next will be separating collision domain. I already explained this. With bridge we will reduce the collision rate of the data. Next will be switched Ethernet. Bandwidth is shared only between the stations and the switch. N-port switch, switched Ethernet. Here, switch is there. Here, domains are there. Yes, sir. Full duplex Ethernet. A limitation of 10 base 5 and 10 base 2. It is a yeah, it is a half duplex. Evolution is switched Ethernet and full duplex switched Ethernet. Here switch is there. Here two transmitter and receiver will be there. Full duplex mode increases the capacity of each domain from 10 to 20 Mbps, because here there is no sharing of the data is there. Media. Full duplex Ethernet. Traditional Ethernet was designed as a connectionless protocol at the MAC sublayer, and for no explicit flow control or error control to inform the sender that the frame has arrived at the destination without the error. For flow and error control in full duplex switched Ethernet, no need for CSMA CD. This functionality can be turned off. Each link is a point-to-point a dedicated path between the station and the switch. Adding a sublayer called MAC control between MAC sublayer and the LLC sublayer. Thank you.